Okay, practice exam 2, point back step 4. So here's this. This is a calculator problem. And let R and S in the figure above be defined as follows. R is the region in the first and second quadrants, bounded by those graphs. S is the shaded region in the first quadrant, bounded by the two graphs, the x-axis and the y-axis. Find the area of S. Okay, so you have to ask yourself, how do you do this? So to find the area, it's either, actually, let me grab this. So, area and volume. Okay, so I'm looking at this. Okay, everybody should be, flipping through these from time to time to get ready for our exam. But so the area and volume formulas are right here. Okay, so for area, you're either going to do top minus bottom or right minus left. And in this case, I guess you could do either, but if you could do top minus bottom, you should do that. Only do right minus left if you have really no choice, or if things are given to you in terms of y. Yeah, so I'm going to go like this. So it's going to be the integral from, something to something. I'll say from A to B, top minus bottom dx. That's what I want. Okay. Because that's the formula. I'm just writing it down. So this is going to be the integral from, and these are x's. So the leftmost x value is 0. The rightmost y value right here, this is where the parabola hits the x-axis. All right, and this is the parabola. So for this point right here, okay, we need 3 minus x squared equal to 0. So you end up with x squared equals 3. So x is plus or minus radical 3. So this is radical 3 right there. Don't estimate, guys. Like, if you did use your calculator to get that, then store it. Okay. So to radical 3. And then I just do top minus bottom. So the top one is, it's going to change. Oopsie. Okay, so up here we need to know that because, yeah, I've got to know that x value. So it's going to be 0 to, whoopsie, because here top minus bottom is 2 to the x minus 0, but here top minus bottom is the parabola minus 0, and it's going to change right at this point. So you'll find this point by using your calculator if you want. So y equals 3 minus x squared, 2 to the x. Okay. And then I go second, cal, intersect. Yeah, so 1, 2. Okay, so it's going to be from 0 to 1, top minus bottom is 2 to the x. And then we're going to pick it up and go from 1 to radical 3, 3 minus x squared. And we use our calculator from here. So I go math 9, 0 to 1, 2 to the x dx plus 1, 2, radical 3, 3 minus x squared. 1, 2, Okay, and so this is, okay, so we'll just be like equal 2.2401. Okay, yeah, guys, use at least 4 decimal points. At least 4 decimal places. Okay, so there's the first one, and I don't have the answer key in front of me, so I don't remember how much that was worth. That might have been 2 points right there. This is 9 points total. I think that was maybe 2, might have been 2 or 3 points. Yeah. Okay, so now B. Find the volume of the solid generated when R is rotated about the horizontal line y equals -1. Okay. So like down here, let's say that this, all right, let's say that down there is y equals -1. And we're going to rotate R around it. Okay. Now, since we're rotating around this horizontal lines are like the x-axis, so everything's fine in terms of x. So, what I need to do now is maybe try to visualize it. So, all right, so this is the center of the rotation. And then this is where we hit the region. So this radius is going to be for like all of that empty space. All right. But then also from the center of the rotation, we've got like this larger green radius that goes to the end of the region. And that is like this space. How do I make this look good? It's hard to. Yeah, so something like that. So we have washers anyway, is what I'm trying to say. So for volume, you have to know these formulas. So instead of, they're very similar to the area formulas, but the input of the integral is the area of a cross section. It's either the area in terms of x, the area as a function of x, or the area as a function of y. All right, and in this case, we'll use area as a function of x because I forget how I explained this. The radiuses are perpendicular to the x-axis, I guess, because we're rotating around a horizontal line. I should just stop talking. All right, so we go like this formula. So x equals a to b, area in terms of x dx. All right, but the area in terms of x is going to be pi times big R squared minus little r squared. Guys, a lot of you were trying to use this, which was very, very good news. It's great news if you even tried to use this. However, you went like this. Okay, so this is not right. Big R minus little r, and then you squared it. Okay, so you were super close. You had the right idea, but it's like this. So we get that a of x is pi. Okay, now big R, you got to do top minus bottom. So top minus bottom for big R. The top is the parabola, and the bottom is -1. So it's 3 minus x squared minus -1 squared minus. And then for little r right here, top minus bottom, 2 to the x minus -1. And then you square that, and then there's that. Okay? And then you can simplify a little bit if you want. Okay, so this will be 4 minus x squared squared minus 2 to the x plus 1 squared. Okay, and then this goes inside of this. Yeah. Okay, that goes inside of that. Okay, but I'll do that in a minute. So this is equal to the integral from x equals what? Okay, so the region, the leftmost x value from the region is here. It's right there. So I've got to find that. All right, so I go back to this, back to the graph, and I probably should have found this at the beginning. So I need that intersection point. So, second. Okay, now this is something I'm going to have to store. All right, so I go back to my home screen. I hit the X. My calculator remembers that. And then I'll store it as like A or something. So I have to say to my reader somewhere that I have room. Okay, so let me erase this, sorry. Okay, so I'll say I'll use lowercase a because I'm using capital A for area. So I'll let lowercase a equal negative 1.636. Okay, I'll just round. I'll round, okay? But we know our calculator has a better thing stored. So, all right, so this point anyway, all right, so this has an x value approximately negative 1.6366 for right there, okay. You've got to say this, guys. If you just say, if you have it stored in your calculator, you do everything right, you get the right answer, they're not going to give you credit because you didn't tell them like what you were doing. So if I'm letting A be that, and then, so I'm getting that the volume is equal to the integral from A, okay, so from x equals A, all the way up to this x value, which is 1. Oh, and you know what? You could pull the pi out front. See how I put the pi out front? Yeah, so the pi is just a constant multiple, so you could put it out front of the integral like that. And then the rest goes inside. 4 minus x squared squared minus 2 to the x plus 1 squared dx equals... Okay, so math 9. Actually, I'll do pi first. Pi. Okay, so I've got the pi out front. And then I go math 9. You could put the pi inside. And then I have A stored, so from A to 1. And then in here, 4 minus x squared squared minus 2 to the x plus 1 squared. Da, 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 yay! Okay, so 63.1067. Okay, so we've got that, and now one more. Okay, so this last one. A lot of times they'll ask you to set up an integral but not evaluate it. And here they're doing that. So the region R, oh my God, is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with one leg across the base of the solid. Write, but do not evaluate an integral expression that gives the volume of the solid. Okay, so I'm bad at drawing these, but for this one, so we've got, okay, so we're going to have, like, I really don't know how to do this. How could I make this look good? Okay, so something, I don't know, something like that. So there's like infinitely many of those like coming up out of R. All right, and this is again a volume thing. So volume. All right, thank goodness we don't have to use horizontal slices because that would involve us having to solve for x. So we're going to use this again. And let me move to this other piece of paper. Okay, so this is for C. So I'm using the volume equals, from x equals a to b, the area of a cross section in terms of x. So let me find a of x. So a of x is 1/2 base times height, because that's a triangle. All right. So here's a cross section, guys. Okay, so this is the base, and we're going to get this base by doing top minus bottom. Yeah. Okay, oh, and it's an isosceles triangle. All right, so this line here, so this blue line that I just drew, that is this blue line right there. Okay, I could have drawn it differently. Yeah, so top minus bottom. So it's the parabola minus the exponential function. So that's the base, and it's also the height. So, so this is equal to 1/2 just like that, okay? So when you're doing this, all right, so this is equal to, in this case, or actually I'll just say it down here. So the volume is equal to the integral from x equals, okay, so again it's this one, so from, and we have it stored as a, from x equals a to 1. And then in here, so this 1/2, it's a constant multiple. So you could put it inside or you could put it outside like this. You could bring that constant multiple out front, this one here. Okay. And then in here we just have 3 minus x squared minus 2 to the x. Oh, whoops. And then we square it. Right, because it's just this times itself. And if you want, the 1/2 can go inside. That's fine. And then that is it. Okay. Alrighty, I will talk to you later.